This video created for junior marine deck officers. Ship handling ideas shown in this video are based on author's 33 years of successful marine career, including 17 years as master on ocean-going ships and marine pilot. However, these ideas are not confirmed by any official research or guidance. In this video I will explain complex task of ship handling by simple, easy-to-understand language. Ship moving in water on very complex trajectory. Complex trajectory of ship is a combination of these three basic movements. Number 1. Move alongside forward to aft axis. Number 2. Move alongside port to starboard axis. Number 3. Swing around pivot point, to port side or starboard side. Here example of ship's complex trajectory. Ship moving astern and to starboard side, no swing, that is constant heading. Another example. Ship moving little astern and to starboard side. In same time she is swinging to starboard. Pivot point of ship is axis of rotation in horizontal plane. Location of pivot point is not fixed. It depends on movement direction and speed of ship. It's simple. If vessel not moving through water, her pivot point is situated at midship. Once ship start moving in forward direction, position of pivot point start moving forward as well. Higher speed, pivot point will move more forward. At full sea speed, pivot point located at about 0.25 or 0.15 of ship's lengths from forward end of ship. When ship moving astern, pivot point also moving astern, about 0.25 to 0.33 of ship's length from aft end of ship. Understanding of pivot point location is crucial for successful ship handling. Reaction of ship on applied force depend on where this force applied in relation to pivot point. In this example, tug pushing exactly at pivot point and 90 degrees to ship's hull. Ship will move to port side only. She will not get any headway or sternway. Heading also will not change. Next example. Tug pushing at extreme forward. Ship will swing to port, but will not get any side movement or headway or sternway. In this case, tug pushing forward of pivot point. Ship will move to port and swing to port at same time. Reaction of ship on applied force also depends on her speed through the water. In this example, ship slowly moving ahead and tug pushing in pivot point. She will move sideway to port side because of tug push, and in same time she is moving ahead. Resulting movement will be ahead and to port. Force lever arm is the perpendicular distance from the pivot point to the line of action of force. Changes in pivot point location leads to changes in force lever arm. In this case, ship speed through the water is 0, rudder hard to port, and engine running ahead. Rudder force moves ship's aft to starboard. Ship slowly starts swing to port side. It is very important to understand interaction of ship's propeller and rudder. Water jet from propeller pushes on rudder at certain angle. Water jet pressure creates side force on propeller and pushes ship's stern to port or starboard side. At the same time, propeller itself pushing ship ahead. Here inertia come to play. Remember, inertia is the natural tendency of objects at rest to stay at rest, unless an external force causes the velocity to change. For ship handling purpose, inertia is very useful natural tendency, because stern of ship easily moves to port or starboard side, but because of inertia ship starts moving ahead very slowly. Before ship accelerate to speed about 1 knot, her heading will change for 10 to 15 degrees. Once ship starts moving ahead, pivot point moves ahead as well, lever arm increased. Rudder force remains same, but because effective length of lever, rudder force is acting upon increased, ship swinging faster. In this case, two tugboats apply identical force, but at different distances form pivot point. It means arm levers are different. Combination of these forces and different arm levers will move ship to port side and she swings to starboard. Environment forces such as wind, current, waves, inertia and drag are always pushing ship from different directions. Ship handler using available resources to counteract environmental forces and move ship in required direction. These resources are ship's engine, rudder, bow thruster, anchors and tugboats. Inertia, current and wind could be used as very useful resource to control ship movements. Let's check each environmental force and control resource, one by one. Wind. It creates pressure on ship's structure above water. This pressure concentrated in point, named center of windage area. Wind force pushing vessel in direction of wind. Wind force could be used for ship handling. Current. It's obvious, vessel moving together with water movement at speed of water movement. Current could be used for ship handling. Waves. Waves can push vessel with considerable force. Waves able to slow down or accelerate ship. Waves can suddenly change ship's heading for 5 or 10 degrees. Waves cannot be used for ship handling. Inertia is the natural tendency of objects in motion to stay in motion and objects at rest to stay at rest, unless an external force causes the velocity to change. It is one of the fundamental principles in classical physics. Inertia could be used for ship handling. Ship's engine. Most powerful resource. Most of the force created by main engine applied in forward, aft direction. Rudder. Create transverse force and move ship's stern to port side or starboard side. Rudder allows to maintain or change vessel's heading. Bow or stern thrusters. Creates transverse force at bow or aft of ship. Use of thrusters is limited. Tugboat. Most versatile and powerful tool of ship handling. Comment about controllable column. Answer no means that ship handler cannot control direction and amount of force. Answer yes in column usable to control ship movement, means that in some cases force may be used by ship handler to control movement of ship. As you see, almost all forces acting on ship could be used to control her movement. Many different forces applied to ship at any given moment of time. Each force applied in different location in relation to pivot point. While ship slow down or accelerate, position of pivot point changes as well. Therefore, reaction of ship on each force, though force itself remaining same, will change as well. For example, while ship slow down, wind force and direction remaining same, but reaction of ship will change, because location of pivot point changed. Ship handling always based on rough estimations, patience and common sense. So, observe, estimate, apply control, patience, and control outcome of your actions. Again and again, continuously, until operation is completed. Patience is critically important for successful ship handling operation. Ship handler need lot of patience. Remember about inertia. It is the natural tendency of objects at rest to stay at rest and moving object to continue movement, unless an external force causes the velocity to change. So, due to inertia, do not expect that vessel will react immediately after you apply force, like rudder, thruster or tugboat. There is a temptation to apply lot of force to overcome inertia faster. Very big mistake. Example, you apply 75% of bow thruster power. Bow thruster force will overcome inertia quickly. However, vessel will accelerate in her motion quickly as well. Then you want to stop her, but due to high motion speed and inertia, you need to apply 100% of bow thruster to stop her. Often even 100% of applied power is not enough to stop quick motion of ship. So, do not be in hurry to apply lot of force. Apply 25 or 30% of available force and wait for some time for reaction of ship. If no reaction or reaction is very weak, apply more force. Watch and adjust. Observe and be patient. Conclusion. You learned that trajectory of ship's movement consists of 3 elements. You learned about ship's pivot point and arm force lever. You learned about different forces affecting ship's movement and controls available to ship handler to counteract and control ship. All these basic principles of ship handling. Watch series of short videos about different ship handling cases, like berthing, complicated anchoring, ship-to-ship operations. Check for ship handling playlist on my YouTube channel. Safe seas and good luck.